Okay? Okay. Okay, so let's start, and welcome to everybody to our talk about developing desktop and web application with Eclipse technologies and EMF. We are Francesco Guidieri and Vincenzo Caselli, that is here. We are founder of RCP Vision, an Italian company based on Eclipse technologies, and here we have Lorenzo Bettini, that is one of our most important collaborators, and also the main contributor to EMF Parsley, our project, that is professor at the University of Florence. And RCP Vision is an Italian company, as I said, that works on Eclipse technology since 2009, and we basically work on EMF stuff, and we do evangelization with our customer and consultancy service in general on Eclipse and EMF. And we do a lot of architectural work with our customer to get this kind of framework working very well. And this talk is about our one challenge that we have to manage in the past month. And we had a big application in a desktop application based on EMF and CDO. It was composed by several views. It was about document management, PDF and image management. And its core business is to acquire data from physical documents with an engine that is based on EMF. And also we use deeply EMF for the UI. So we had to migrate this application to the web. And we have been surprised by how easily we can do it for, in a couple of weeks, so a very few days. And we started asking ourselves, how was it possible? And the answer is probably that we used some good technologies and some good pattern, and so we can change. We could change from a UI layer to another one. And these technologies, the first one is obviously EMF, that have a great runtime and a great edit framework. Then we use EMF Parsley to build the UI, reflective UI with the model. Then we have a persistent layer that is based on EMF resource APIs. And we deeply use inversion of control with a framework like Google Guice and OSGI services. So our goal for this talk is to build a proposal of an architecture that is independent from the persistent layer and for the UI technology. So it can be for the web and for the desktop application. And for what concern RCP application, desktop application and web application, we used RAP. That is a framework that lets you use the single sourcing between SWT library and RWT library, that is the library of RAP. And here you have the link to the project. And for persistent implementation, well, it's quite easy for EMF because we have a lot of persistent mechanism EMF. We have the standard XMI implementation. We have a lot of framework that implement repository, like CDO, EMF store, and so on. And or Teneo for the DB, that is based on Hibernate. But what happens when I want to go to a legacy DB? And we used MyBatis for that. And so in this example, you can find an implementation made on MyBatis. So in this talk, we will see some theoretical slides on patterns that we revised and applied to our architecture. Some snippet of code for the most important stuff, and then we will see a demo of the example. So let's start with some slide on the architecture. As you can see, we have a central part that is common with a UI layer, a presenter layer, and a service layer with the model. And then we have defined some APIs as repository APIs. We will see the repository pattern in some minutes. Then we can switch between RCP and RAP by switching the target platform, simply switching the target platform. And we have 3 different implementations of the repository API. And we plug this implementation by OSGI services. So here there is a little simulation of a querying for object to do with. We have the UI layer that asks for the object to be shown. Then we have the presenter layer that's called the service layer that implements the business logic and knows which repositories are involved in that query. Then the repository layer that creates the object, query the persistent layer, creates the object. The presenter layer that prepares the object for the visualization, we will see in the demo. And then the UI layer that performs the data binding. So the model object and the UI controls are strictly coupled together. We used a model view presenter like pattern, not the original one, but we used a little revisitation of this pattern because of the data binding, because we want that the view controls and the model elements are binded. So we have the data binding, and the presenter implements all the the logic control for the view, and then prepare the model. We have a fully EMF compliance, and if you want to use EMF properly, you have to deal with some mechanism of EMF. First of all, the resource APIs, the editing domain, and all adapter factories that are needed to customize. I don't know if you remember this advertisement for car tiers. The power is nothing without control. So if you can control this framework, EMF edit, you can have a lot of things for free. The UI model data binding, a great notification system with editing scoping, and more advanced features like validation, drag and drop support, all for free. But how can control this framework? Well, we use EMF Parsley. EMF Parsley let you use EMF edit feature in a very easy way, because we hide a lot of details of the EMF edit layer and provide some components that are ready to be used. And then there is a great DSL, can I say great? DSL for the customization. And another important thing about Parsley, Parsley is out of the scope in this presentation. So, but another important thing is that it let us access to the injection of Guice, Google Guice. We will see in a minute. So here we have a view that implements a table form with a master detail mechanism. So you can select one row of the table and have the detail. And you can see the implementation. You cannot see the implementation because of Parsley, because Parsley hides all the details. And so you have the Parsley injection. You can use the table form factory to create a table form master detail composite, and then set the inputs and stop. And Parsley will take care to do all the stuff. And another important thing in this view is the use of the presenter. As I said, in the model view presenter pattern, we have a little, the view uses the presenter. So can inject the presenter and then initialize it. The presenter provides the input for the viewer because he has to prepare the object before the visualization, and then provide the implementation of the control logic. So here we have a utility class that creates a selection adapter and take a lambda as the implementation. This is Java 8 syntax. So you can see that it's readable. And another thing, important thing, is the injection that we can use with generics. Here you can see that I define an abstract viewer presenter that manages the T object. T defines the object that will be shown. And then I'll define that I'll use the service S that will manage the object of type T, and I can inject directly the generic. And when you specialize this class and you define the generic, Google Guice will inject the right type. It's very powerful. Okay, let's go to the example. The example is a simple application for rent a car. So we have the user, the vehicle, the car, and then a little object for the reservation. So you can put the user, put the cars, and then reserve the car for the user. Very simple. But we have to implement both implementation for the model for CDO and EMF. And if you are familiar with CDO, you know that CDO is a different implementation from EMF. So a CDO object is in an E object, but the implementation of a CDO object is different from the implementation for EMF object. And so we have two different implementation. And we use a single plugin to define the model and two different gen models to generate the two implementation into two different plugins. We will see it in the example. But how can I manage these two different implementation of the model and the different implementation? Sorry, this is the structure of the workspace. The source will be available on GitHub, and this is the structure of the workspace. We have the first two are the CDO server definition, that is a feature in the product configuration. Then we have the two application, one for RAP and one for SCP. They are simple, empty application without any implementation. Then the model with the 3 plugins, the coherent CDO and XMI. Then we have 4 plugins for the repository, 1 for APIs and 3 for the implementations. And then the UI example and the service layer that are common for all other, so single sourcing for the logic and the control logic. And then the last is the target definition for RAP that is taken from is available from the examples of EMF Parsley. So how can I manage all this stuff together? The first is regards RAP and RCP difference. I can use the optional directive in the required bundle section and refer the standard SWT plugins and the RAP plugins together with optional. And then I can switch between the two targets without any problem. For the model is a little bit harder because I have to use import package instead of required bundle, because the two plugins of the model define the same packages, these 3. So using import package, I can refer both the implementation, and then I need to declare the CDO specific plugin as optional, so they will be used if present in the runtime. Okay, let's go to the persistent layer. We have used the repository pattern that made a separation between the domain model and the data model. So it says that you can use domain model as a set of collections of objects. And then the repository will carry out all the stuff to persist and load the data. And this is very similar for what concerns EMF resource. You have get contents, that is a list of the objects, and use them to do the stuff. So we have an implementation of the repository that is based on resource API of EMF. You have the simple method for insert, update, and delete, and the query methods. This is the standard repository API definition. And then we have made 3 implementation of that APIs. A dummy implementation that is based on mockups object, but fulfills the task to provide the same API of the other repository. We will see in the example. Then we have the CDO implementation that is based on CDO, so is real objects on the DB, on the repository. And then we used MyBatis that is a simple data mapper that lets us go to use any kind of legacy or existing DB, because you have to implement the data mapping. So here are the source of the example that we are going to see, and you you'll find two different applications, one for SCP and one for RAP, with 3 launch each. That are the 3 persistent implementation. And for the IDE, we recommend to install Oxygen modeling package that contain all the modeling requirements. Then you can add the RAP tools from Oxygen update site. And for MyBatis, we use the MyBatis generator, that is an Eclipse plugin that generates the data model from the DB. Okay, and then we will switch between the running platform, that is a standard SCP platform, to the platform that comes from EMF Parsley for RAP. So, let's see the demo. We will see 2 applications that are very similar. One is an RSCP application, and the other one is a RAP application. So, let me switch. Maybe. No? See? Okay. Okay. So, here we can see that I have 2 different target platforms. One is the running platform, that is this Eclipse, the current Eclipse. The other one comes from EMF Parsley, is a simple RAP target platform with modeling stuff. So, I can start from this, and here we have the projects. Let's start with the dummy implementation. Okay. I have a web application with a table form mechanism. Then I have I can insert a new object. Please note that there is no ID in the left. And then I can save and see the ID. This is a dummy implementation, but we simulate the presence of the DB, okay? Like a sequence. And then we have the vehicle view, where, of course, another thing is that we highlight changes. So if I change something, you have the green line, and if I save, the green line disappear. And then in the vehicle view, also, I can insert a new vehicle, obviously. Then I can change the type. You can see if I change the type, the image changed. And then these things are very simple with modeling and with Parsley. Okay, so I can save, and then I can make a reservation. So I reserve for Francesco. I can see that the picture is changed. Okay, so very simple demo, but demonstrates some mechanism for that are very useful. So let's see another implementation. I can. Let's see MyBatis. Okay. Here I have a DB, an Oracle DB, with some data. Then here we have the representation, and the behavior are the same of the dummy implementation, of course. So I can insert something, save. I can change something and see the green line, save, the green disappears, and so on. And the same is for the CDO. I probably need to start the CDO server. Okay, here. Started, and then run the client. No problem. Okay. And here we have the CDO ID on the left. So I can insert a new person, save, and get the new ID. So the same behavior. And I would like to show you the change of target. So I need to switch to the other target, wait for the build, then I can close, okay, open the other project, that is the SCP application, maybe clean, okay, and then I can run the dummy example in SCP. Uh-oh. Maybe. Yes, there is a little bug. Because of the two model, because we use in the DSL X base, and probably there is something that's misunderstood with two model. I have to close the CDO, reopen that, and all works. But it's not common to have all these different implementations in the same row spaces for the demo. So restart the application, and maybe, okay. And here we have the SCP version of the application with the same behavior, exactly. Save, ID, the green line, save, disappear, and so on. So I think we probably, I have also the other two demo, but there is no time to do that. But you can try it as an example. So, yeah.
Change the image of the
Yeah, of course. A little snippet. With Parsley, if you want to customize the view, you can use a DSL. This is our DSL, and this is the part for changing the vehicle type, the van and the car. So there is the if type equals van, show van PNG, otherwise show car PNG. Simple. Because Parsley carry out all the difficult part and hide it. Okay, so let's go back to the presentation. Maybe? Yeah. Okay. We are organizing an event in Italy, in Milan, for September. So please feel free to contribute or to attend this event. this great event in Italy. And thank you for your attention, and remember to evaluate this session. If there are questions. Yeah?
So did you face any problems with RAP? Because we had a lot of them. So we had missing SWT features, and for the existing application, we had missing platform features that were in the platform for a long time. We had scalability issues. Users staring a lot of like spinny wheels because there was so much communication, because the server tracks the UI state, right?
Yeah.
So did you run into any of those problems?
Well, we had some problem with the SWT API because not all the SWT is implemented, and some graphic canvas and so on. And not so much for what concerns performance. Yes, there is a communication between servers and browser, yeah. But we didn't see, so we didn't have big problems about. Yeah. Some other question? Okay. So thank you for attending, and